Right, so this question we could probably do with drawing a diagram to see what's going on. So we've got our slope because we've got a ball falling towards it with mass m. It strikes a smooth fixed plane. This is angle alpha. Immediately before it has speed u, and once it strikes the plane, it moves off in a direction which makes an angle of 45 degrees with the plane. And there's a bit more information. Right, so we've got to find the magnitude of the impulse on the ball. Then what I did just to visualize this was look at the speed as it comes down and hits the plane. So there's u. Now if I extend that down there, this angle is alpha. So I can then think about, so that angle would be alpha, and I can think about what's going on here. I'm going to want to resolve parallel and perpendicular to the plane. Now when I do that, that's going to turn out, if I work through it, that that angle there is alpha. Okay, so my initial velocity split into two components, so parallel to the plane. I can now see from my diagram, so that's in this direction. So that would be u sine alpha. And then if I look perpendicular to the plane, that would be this way, so adjacent to alpha, so that's u cos alpha. Right, so then what can I say happens? Well, parallel to the plane, there's going to be no change in the component of velocity. So afterwards, we know it's an angle of 45 degrees, so if I call this v for the final velocity, I can say that v cos 45 degrees, I'm going parallel to the plane now, is u sine alpha, so no change. Okay. If I look perpendicular to the plane, I need to use my coefficient of restitution, so we're going to do speed of separation, so that's going to be v sine 45 degrees, it's perpendicular to the plane, and then the speed of approach was u cos alpha using what we worked out earlier. From that, we can then use that to work out that E equals tan alpha. So if I use my two equations to get sine alpha divided by cos alpha, we can see that's going to cancel out to give us E as tan alpha. So rearrange your two equations to get sine alpha, cos alpha, divide them, and get that E is tan alpha. Right. Also perpendicular to the plane, we can use my impulse is my change in momentum. Okay, so that's going to be mv sine 45 degrees. So we're looking perpendicular to the plane, plus mu cos alpha, because there's a change in direction involved, so we go one direction and then we're bouncing back. So that is going to be, if we just factorise out the m and the u, and we can get E cos alpha plus u cos alpha. Okay, so I've still got cos alpha in here. So I'm going to need to get rid of that. I can then do further factorising. So I've got this bit, E plus 1, oh, and I've left a u in there. Get rid of that one, I factorise the u out, cos alpha. Okay. Now, you're actually most of the way here, so we wanted impulse in terms of m, u and e, but I've still got a cos alpha in here that I need to get rid of. Now this is where you need to now use something that you've learnt in core maths. Okay? So I know E is tan alpha, and I need to get rid of a cos alpha. Well, what trig identities do we know? So we know, for example, tan squared alpha plus 1 is sec squared alpha. E is tan alpha, so E squared plus 1 is 1 over cos squared alpha. So cos alpha is going to be 1 over the square root of E squared plus 1. Remember, we know alpha is between 0 and 45, so I'm going to take the positive values, the positive root. That means I can sub that into here. Okay, and then I've got my impulse in terms of M, U and E, which is what they were looking for.